All right, let's pull back the curtain on your digital life for a second. Ever wonder about that invisible force? The one that keeps your favorite apps running perfectly? Or maybe more often, the one that makes them crash right when you need them most? Well, we're going to dive into that. Okay, picture this. You're in the middle of doing something important, booking a flight, firing off a quick text, maybe just ordering a pizza, and bam, the app just freezes, or it crashes, or it just starts doing something totally weird. It's so frustrating, right? Yeah, we've all been there.
So, that incredibly annoying moment? That's what the pros call a software failure. But what's really happening behind the screen? In this explainer, we're going to perform a little autopsy. We're going to investigate the secret life of software bugs and, maybe more importantly, the people whose entire job is to hunt them down.
First things first, we've got to understand the culprit. We throw the word bug around all the time, right? But in the world of software, it's not that simple. There's actually a really specific chain of events that leads to a crash. And believe it or not, it almost always starts with a simple human moment.
Okay, so it all kicks off with a human mistake. We call that an error. Just imagine a programmer. Maybe they're a little tired, a little distracted, and for just a split second, they type the wrong thing. That little error creates a hidden flaw in the code, a defect. That's what we usually call a bug. But here's the thing. It just sits there dormant, totally invisible. It only turns into a failure, the thing you see, when you happen to do the exact thing that wakes up that faulty piece of code. And that's when the app crashes or starts acting weird.
And a failure isn't always some big dramatic crash. The official definition is simply a departure from expectations. So if a button is supposed to be blue but it's showing up green, that's a failure. If a calculation is off by a tiny amount, yep, that's a failure too. Basically, it's any time the software doesn't do exactly what it was supposed to do.
So who stands between all those hidden defects and your experience as a user? Well, this is where our unsung heroes enter the story, the professional software testers. And I'm telling you, their job is way more nuanced and interesting than you probably think. But before I just give you the answer, take a second. What do you think a software tester's main goal is? Is it to find every single bug out there? Is their job just to break things? Or maybe to prove that the software works perfectly? What do you think?
Okay, so here's the key insight. Their job isn't to find every single bug. I mean, that would be completely impossible. Their real mission is actually to manage risk. Think of them like quality detectives. Their job is to gather evidence to answer one super important question. Is this software good enough to release to the public? It's their work that builds the confidence to finally say, yep, let's ship it. So how in the world do they manage that risk? I mean, how can they possibly check every single thing a piece of software can do? Well, the short answer is they can't. And that's exactly why they have to be so clever about it. This is where their secret toolkit comes into play. This is one of the absolute fundamental truths of testing. For any piece of software that's even a little bit complicated, the number of possible things you could type, buttons you could click, and paths you could take, it's practically infinite. You literally cannot test everything. It's impossible. So testers have no choice but to be smart. They have to be incredibly efficient. So one of the most common ways they do this is with something called black box testing. I want you to imagine the software is just this sealed, mysterious black box. You have no idea what's going on inside, you can't see the code. All you can do is put stuff in, those are the inputs, and then watch what comes out, the outputs. You're basically just checking to see if the box follows the rules you were given. Let's make this real with a simple example. This is actually from a professional certification exam. Imagine you're testing a search form for an apartment rental website. You can pick a floor, and you can pick whether you want a garden. Now, there's only one rule. Only ground floor apartments are allowed to have gardens. So the big question is, how many different tests do you think you'd need to run to feel pretty confident that this feature works?
The answer is just 3. Yeah, only 3. It sounds kind of crazy, right? But this is where the cleverness comes in. Instead of trying to test every single possible combination, they just test each type of valid option. So they'll do one test for a ground floor apartment with a garden, then one for a first floor apartment without a garden, and finally, one test for a second floor or higher apartment also without a garden. With just those 3 tests, they've intelligently covered all the valid possibilities. It's a perfect example of working smart, not just hard.
But just finding the defect, that's really only half the battle. The truly great software teams don't just patch up the bug and move on. No, they try to figure out where it came from in the first place so they can stop it from ever happening again. This is where they really put on their investigator hats. And this is such a huge difference. It's the difference between a quick fix and a real solution. See, troubleshooting is kind of like taking a painkiller when you have a headache. It makes the symptom go away, right? You just restart the server, and for now, the problem is gone. But root cause analysis, that's like the doctor running tests to figure out why you have that headache, so they can actually cure the illness that's causing it.
A really powerful technique they use for this is called the 5 whys. It's simple. You start with the problem, and you just keep asking why over and over, kind of like a little kid. So the problem is a log file is missing. Okay, why? Well, because the feature wasn't turned on. Okay, but why? Because the app wasn't configured correctly. Why not? Because a crucial setup step was missed. Why was it missed? Because the instructions, the documentation, it wasn't clear. And just like that, you see what happened? A technical problem, a missing file, led us straight to a human process problem, bad documentation. Now, if you fix the documentation, you prevent this whole category of problems from ever happening again.
So when you take all this stuff and put it together, this professional mindset, these really clever techniques, this deep dive kind of analysis, what do you get? What does it all add up to? Well, it adds up to one thing: quality. And having this serious commitment to quality pays off in a huge way. I mean, finding a bug early in the process is so much cheaper to fix than finding it after it's already in the hands of customers. And what does that mean? It means lower costs, it means faster development, and really the most important thing, it means happier users, people like you and me who get to use something that's smooth and reliable. And it's so important to get this. This is not just some random, informal job someone does. Software testing is a real, complex, and super demanding profession. I'm talking entire career paths, huge bodies of knowledge, and even international certifications, like the ones from ISTQB, all dedicated to the science, and you could even say the art, of making sure software is high quality.
So the next time you open an app and it just works, seamlessly, flawlessly, exactly how you expect it to, just take a second. Of course, you can thank the designers and the developers for the work you can see, but maybe also give a little thought to the invisible work of the testers, those unsung heroes who found and fixed all the failures that you never even knew were there.